Hello aspirants, a very warm welcome to you all. My name is Madhusudan Reddy and I am the Faculty of Geography and Environment for you. We have already covered 6 major themes, and in the last series we have covered about climatology, that is part 2. And in today's lecture we shall be covering the next theme, that is your oceanography. So this oceanography is present in class 7 also, class 11 also, but you are supposed to study only the important chapters, that is go to class 7, read chapter number 5, class 11, chapter number 11 and chapter number 13 and chapter number 14. In the class 7, some fundamentals and basics about water is written here. The same thing is also repeated in your class 11 and 11 and the physical geography as well as the fundamentals of physical geography, class 11 and India environment physical, little basics are written there. So we'll try to understand all these chapters in a go, right? So let me again repeat: class 7 chapter number 5, class 11 chapter number 13, chapter number 14. The names of these chapters are 1. Water and oceans and movement of the oceanic water. So these are the chapters that we need to go through in a detailed manner. Now first let me scroll down what exactly is the content that is written in these chapters, and you are supposed to study them as a theme. Number 1, you in the class 7, the chapter number 5 talks about water. It is about the cycle of water, the rate of evaporation as well as precipitation, and then the flow of water. How does the water move in the atmosphere? This is what is written, as well as some seas and distribution of the bodies. See, this particular chapter also tells you about the distribution of oceanic water. Oceans consists of 97.3% of the total water that is present on the earth, and this is all saline. Rest of the water which is there, it is considered to be fresh water. We'll be looking into where exactly is the highest amount of water that is present in the form of fresh. We shall look into in detailed manner. This is also there in your class 11. And apart from that, the ocean circulation, how the water circulates, they have written, and in total a brief about the oceans they have given an introduction here, right? Also they talked about tides, ocean currents, right? The same thing in an explanatory manner. You will also see a similar kind of map in your class 11 as well, which talks about the movement of the oceanic water. The movement of the oceanic water, how the cold oceanic water from the polar region would come to the equatorial region, and the warm equatorial water, how are they moving towards the polar region. Now what are the factors, what are the primary factors, what are the secondary factors? We shall be looking into them in a detailed manner as well, right? This is what is given in your class 5. Now class 11 and 12, 11, the chapter number water oceans, the same content is little given in an elaborative manner, right? Now this is little deeper, and for a person to understand this, definitely they need to have a basic knowledge. Without that you won't be able to understand anything and everything here. So I'll be explaining you in a detailed manner about these chapters and the theme of oceanography and how does the movement of the oceanic water takes place, be it your waves, be it your tides, right? So different types of tides is also given here. Apart from that, what are the different types of oceanic currents, and today we'll also learn about the surface water currents and deep oceanic water currents in a practical understanding. I'll keep it as simple as possible, and I'll try to give you the best explanation that you could ever have in your lifetime, right? Okay. If you do have any doubts, you can also message me on 7382552230. This is my personal contact number, and any doubts that you have, I'm always there to respond to you. Right? Don't expect an immediate reply. Definitely within next 24 hours, I'll definitely get back to you. Now quickly come back and let's try to understand what exactly we would have to know from these chapters. See, look here. First, you need to know where exactly is the water present. Where is this water present? See here, the water on the earth, if you broadly look into, it is present in these forms. Imagine the total water that is present on the earth is 100%. Let's say 100% or 100 units. In this, 96.5% is present in the form of oceans, and rest of them, only 2.5% is present in the form of fresh water, 0.09 as saline water, right? That means only 2.5% of the total water that is present on the earth we can utilize for our human survival as well as agricultural purposes also, right? Which is present in the form of ice caps, which is present in the form of groundwater, lakes, freshwater lakes, like that. Now, if you broadly take this freshwater into account, let's say I've taken this 2.5 percentage of the freshwater and I equate it to 100%. Okay, I equate it to 100 units or 100%. Then out of this, 68.7% of the total water is present in the form of glaciers, which is present in the North Pole, South Pole, and some mountains across the higher fields, maybe in Himalayas, Alps, Andes, like that, which we have already learned. Next, 30% of the water is present in the groundwater, right, which is in the ground. Surface water, that is surface fresh water, is only 1.12. Now come to the surface fresh water. Within this, you equate this 1.2% to 100%. You will learn that this surface water is present in the form of permafrost. Permafrost is a region where permanently frozen, right? Polar region. Next, lakes, 20.9%, and atmosphere is only 3%. And further, soil moisture has 3.8, swamps has 2.6, rivers has very less amount of water. The total amount of water that is present on the rivers is only 0.49% of the total available surface water. I'm only talking about total available surface water. You think that the water in the rivers are too high. No, the water in the rivers are very less. Now, where do you find the highest amount of fresh water? It is in the form of glaciers and ice caps. These glaciers are present in the high mountains. They are also present in the polar regions, right? This is how the distribution of water is there. The same thing is also written in your NCERTs in a brief, right? Now, let's quickly come to understanding the fundamentals of this. See, there is a water cycle that you need to know. This water cycle tells you very fundamental things. That is water cycle, or which is also called as hydrological cycle. The hydrological cycle says the water that is present on the earth, the total volume is always same. Okay, the total volume of water is always same, but they change their form and come back in different form. For example, you see there is oceanic water. This oceanic water will start to evaporate in the presence of the heat. Once they evaporate, they tend to form clouds and wind. They start to move from one place to another place, and then they shed their water. The same water evaporated and converted into water vapor, that is H2O, and then it has changed itself into clouds and wind. They move under the influence of the pressure belts. So likewise, whatever they are evaporating at one place, they don't shed their moisture in the same place. Rather, they move and then they give the space to evaporate again. So likewise, here the clouds will move from one place to another place and shed their moisture, and the water comes back in the form of groundwater, runoff water, and comes back to the same place. Now this is a cycle. In the dew process, we use these services. What do? This service of evaporation, the service of precipitation, right, and the service of condensation. Look here, we are using this service of evaporation, service of precipitation, and service of condensation for the benefit of human beings, right? Can I say that water is a natural resource? Here, water is a natural resource, and precipitation, evaporation is a natural service. Suppose if the water available on the ground is a polluted one, only the fresh water will evaporate, right? And then they evaporate, they convert into cloud, they give the rainfall, and the rainwater is comparatively fresher. So in fact, this is a service. This is a natural service. Through natural service, you get some good benefits out of it, right? Through these natural services itself, we are able to utilize the water. Had if the evaporation only takes place on the sea and in the same place the rain falls, would you have monsoons at your continental area? No, right? So there is a dynamic entity that is which is inclined with the earth. This dynamism is what we have to understand. Now this is what is given here. The same amount, the same content, whatever I have shown it to you in the form of where is the water present. The water is always present in the form of the polar ice caps, which is the highest amount, right? So there is a process of evaporation, there is a process of condensation, there is a process of precipitation, right? These are the three processes that are involved. Now here you need to know about the divisions of the ocean floor. Now let's quickly come to the topic of divisions of the ocean floor, that is relief of the ocean floor. As we go deep into the oceans, what kind of floors do you have? What kind of landforms that you get to see? That is what we need to know. Now quickly let me show you this particular entity. Come here. See, the way you think of oceans, it is completely different. Our oceanic floor is having more mountains than that you see on the surface of the earth. We have more water than you see on the surface of the earth. There are more forests which you see on the surface of the earth. There are more forests in the ocean. There are more species in the ocean. Likewise, there are more volcanoes within the ocean. Ever think of the bottom topography of the Indian Ocean? Now let me show you the bottom topography here. The bottom topography of the Indian Ocean does look like this. It is very surprising to see the bottom topography here. Look at this bottom topography of the Indian Ocean. Just a minute. Watch this video. Imagine I've taken all the water. If I've taken all the water, the bottom topography would look like this. Okay? This is your bottom topography. You also have plains, you also have mountains, you also have various kinds of landforms, right? So in a nutshell, look at your ocean bottom topography of Indian Ocean. This is a plain area, but when you go to the little more details into this, you will understand that our ocean bottom topography is very dynamic. It is very important for us to understand. Now, why do you have these mountains? Why do you have all of this? These are all because of the plate tectonics theory, right? It is because of the plate tectonics theory. Imagine these are your mountains. Now, all of these mountains are volcanic mountains. They are called as middle oceanic ridges, right? You also have mountains here within the ocean. And current affairs, there is a mountain by the name Afanazi-Nikitin Sea Mount. This Afanazi-Nikitin Sea Mount which is there, this is the place where India wants to go and explore polymetallic nodules. What is this polymetallic nodules? Please Google and let me know that why is this polymetallic nodules very important, right? India is trying to explore the polymetallic nodules. So you should know why is this polymetallic nodules very important for us, right? Okay. Now come back. We first need to understand the oceanic floor. The oceanic floor is nothing but as you move from the continental area towards the ocean. So what kind of landforms do you get to see? Your Pacific Ocean is different from your Atlantic Ocean. Look at, there is a chain of mountains that are present in the Atlantic Ocean. Now there are landforms that are given names to this. We have to understand the names that are given to these landforms. Let's quickly deal with the landforms. Now see here, imagine that this is your continental area. Okay, this is your continental area. This is a house, this is a house. Let's understand that that is continent, and then you have your ocean here. Let me draw first. Let's try to understand this. Imagine this is your water, this is your ocean. Okay? Let's imagine that this is your ocean. The topic that we are going to study and understand is the distribution of oceanic floor, or the understanding the ocean bottom relief, right? Imagine this is your ocean. right? So as you move from, let's imagine there's a person, he wants to move into the bottom of the ocean. This is 0 kilometers height and this is 5 kilometers height. Okay, let's imagine that this particular depth is 5 kilometers depth, right? Now as you move from the continental area towards the ocean, the first landform that you will come across is the continental shelf. This is your continental shelf, right? Now from the continental shelf you go little deeper. This is the place where the steep is very slope. Let's say this is the slope. The steep is very slope, right? The slope is very steep, not steep is very slope, I'm sorry. The slope is very steep, right? So this slope which is there, it is called as continental slope. And there's a small rise at the bottom. You will find this rise as continental rise. So including continental shelf, continental slope and continental rise, we call this as continental margin. We call this as continental margin, right? Continental shelves are very, very important. Why are they important? They are important because this is the place where you will find oil, natural gas, shale gas, all the major sediments that are there, they are present here, right? When it comes to continental slope, it is very steep. Any river that is coming into the continental slope, it is going, any river that is coming onto the continental shelf, it goes deeper, and then on the slope it moves faster and it will deposit all its sediments in the bottom area. These sediments will become as continental rise, right? So the angles, when you look into the steepness of this continental slope, is very gentle. It will not be very steep. Imagine this is your continental shelf. The continental shelf will be having only 1 degree of slope. This is 1 degree of slope will be there, whereas slope will have 2 to 5 degrees. Continental shelf will have only 1 degree of slope. Continental slope can have 2 to 5 degrees, and continental rise, this is the area of deposition, right? So any side of the ocean, if you are finding continental shelf, continental slope and continental rise, they are called as passive margins, passive margin of the continent. In simple words, I can say that this is the same area where you got to see that the extension of the continent has taken place into the oceans. Now look into India. Where do you find a wider continental shelf? The continental shelves are wider with respect to the western coast. The western coast of India has wider continental shelf. When it comes to the eastern coast of India, it has narrow continental shelf. Now you tell me, why do you have western coast of India has wider continental shelf and eastern coast of India has narrow continental shelf? Why? What is the major reason for the wider and narrower continental shelves? Yes. If you know the answer, let me know. What is the reason for the wider continental shelves in the west coast and narrow continental shelf in the east coast? See, the reason, if you know it, you can also drop me a message. That is, you can also let me know on 7382552230 if you know the answer, right? Next, come to the areas across the globe. Look here. You go to Persian Gulf. See, Persian Gulf, this is your continental shelf, this which blue color. This is having a very wider continental shelf. Now, such wider continental shelves which are there, they are actually very important for exploration of the seas. You will have seas here. This exploration of oil can be done. The sea can explore oil. So, wider continental shelf means you will have oil, because this is the place where river comes and deposits. Maybe there is dead and decaying material. It was buried with this continental shelf, and what are the material that is there on the continental shelf? You'll have good amount of oil. You can explore that oil for few hundreds of years, right? Now come back. So this is what you need to know about the continental shelves, right? Now come to the next component, that is continental slope. So continental slope is 2 to 5, continental rise is the depositions that are taking place. Sometimes on the continental shelf and the continental slope, there could be a river that is present. Now let me take you to the Ganga river. Look at this Ganga river. This is your Ganga. Now this Ganga river, it enters into the ocean. When it is entering into the ocean, it is, can you see there is a crack that is present here? Can you see there is a crack that is present here? This crack which is present on the continental shelf and continental slope is called as submarine canyon. This is called as submarine canyon. Right? ये आपका submarine canyon है. Likewise, these kind of submarine canyons are also present on the west coast of India as well, by the name of Indus River. Look at this Indus River also, which flows on the continental shelf, is cutting. It cuts the continent. So this is called as submarine canyon of the Indus. Likewise, you will also have multiple canyons. These canyons are present wherever the river enters onto the continental shelf and it is dissecting the continental shelf. Right? So you are clear with these aspects. Now where do you find the wider continental shelf? The wider continental shelf is always present near to the polar region. Look at this polar region. Here the blue color component, light blue color, this is light blue color area is the continental shelf. Now you open your atlas and also check. Your atlas will also demarcate the continental shelves to be lighter color. There is a color variation. Can you see the color here is dark blue, but this is light blue. All the light blue color area within the ocean, the depth is not too much. Sometimes 20-30 meters or hardly 100 meters will be there. Fishes will be there. Continental shelves will have good number of fishes. At the same time, you will also have good amount of oil that is present there. So that's why continental shelves are always an asset for us. In this context, I also want you to go and do some homework and please read about UNCLOS. Will be in current affairs. What is UNCLOS? If you have a continental shelf, how is UNCLOS able to help you extend your area? See, if you have a wider continental shelf, you can also extend your area and claim that ये मेरा ज़मीन है. ठीक है? So that is the relation. I want you to go and read about the UNCLOS. Consider this as a homework and please read about it. United Nations Convention on the Loss of Seas. Okay. So the wider the continental shelf, the more will be the asset. You can explore oil, you can explore fishes, and you can have good industrial setup in that region. You can also set up ports. Now look onto the east coast. देखो east coast पे ना, east coast of India has good amount of rivers. This Ganga river, here you have Mahanadi, here you have Godavari, then Krishna, then Kaveri. So there is a lot of sediments that are depositing here. And for the setting up of the ports, it's not that easy. But you have a wider continental shelf, you can easily set up your ports here. You can easily set up your ports here, right? So that's why India has, the western coast of India has more natural ports than on the eastern coast of India, right? This is what you need to know about the continental shelf. And continental slope is a steep slope. Anything that falls onto the slope will be falling faster. And then you have continental rise. Come to the next component. See, within the sea, you will find many mountains. All of these mountains origin can be because of folding or they can be because of volcanic activity. So if there is a mountain that is not more than 1000 meters, if it is not more than or it is less than 1000 meters, we call this as, this particular landform is called as abyssal hill. Abyssal hill. If the mountain is more than 1000 plus meters, then this is called as sea mount. Right? Sometimes these sea mounts can rise and present above the surface of the earth also. If it is coming above the surface of the water, then these islands are called as the sea mount islands. Okay, this is your sea mount. Likewise, if there is a mountain, if this mountain is having a flat top, the top of the mountain is flat, this is called as guyots. ठीक है, this is called as goyots. Now come to the middle of the ocean where you find the ridges. Ridges are nothing but these are your mountains, and these mountains are series of mountains which are primarily formed because of volcanic activity, right? From beneath the interior of the earth, we have already learned from beneath the interior you will get to see there is a rise of the volcanic activity, and this rise of the volcanic activity which leads to the volcanic mountain formation on either sides, this is called as the middle oceanic ridge. They are called as middle oceanic ridges. These are middle oceanic ridges. If you are finding a plain area, imagine this is your plain area in the bottom of the ocean. This plain area is called as abyssal plain. This is abyssal plain, right? Now the deepest points of the ocean, they are also called as the trenches. This is the deepest part of the ocean. This is called as the trench. If suppose there is an area which is having continental shelf, and this is your continental slope, and if there is no continental rise on one side of the margins of the continent, then you will call this margin as an active margin. This is called as active margin of the continent. Whereas you will call this particular margin where you will have continental shelf, continental slope and continental rise, and you do not have the trenches. Trenches are the deepest part of the oceans. You will call this part as passive margin. So this is how your oceans are located. Now on a practical note, if I take India and let's try to understand the ocean bottom topography of the Indian Ocean. See here, your ocean bottom topography of Indian Ocean. I'll point out the stencil, you let me know what exactly is this, right? So in your mind you can think of that these are what are these mountains? These mountains are middle oceanic ridges. They are middle oceanic ridges. What is this plain area? This is abyssal plain. Abyssal plain. Now can you see this mountain? This is sea mount. This is a mountain which is sea mount. And if they having flat tops, can you see this plateau which is flat south of Madagascar? This is called as guyots, right? Continental shelf, this is your continental shelf. This is continental shelf, right? And then you have continental slope and continental rises also on this side. Likewise, you will find different kinds of topographies in an ocean, and all of these topographies are very, very important. And see, an ocean has multiple topographies. You might also think that where is the trench? See, India has trenches. Here you have Sunda trench. Here these are the deepest trenches which you will get to see across the plate boundaries. That is called as Sunda trench. Now come to the bottom topography here. Let me show it to you in a little different manner. This is how you will come across. Please watch this. Continental shelf up to 200 meters. Can I say coral reefs can be present here? Sunlight is very well available here. Come to continental slope up to 3000 meters it can go. And if a river is flowing on this particular area and this river can cut down, this is also called as, if it is cutting apart, that is also called as submarine canyon. Now come to continental rise. It is because of the deposits that are taking place here. These are the deposits, and this is your abyssal plain. Maybe this is your trench. Deepest part of the ocean is called as a trench. If there is a plain area, this is called as abyssal plain. This is abyssal plain. This can be volcanic island or volcanic arc. And submarine ridges, these are middle oceanic ridges. If you have a mountain here, this mountain is called as sea mount. And if you have a flat topped mountain, this is called as guyot. If the size of the mountain is small, this is called as abyssal hills. In a nutshell, this is how the ocean bottom topography is present, right? Now come to the next component of your chapters, that is the major part of the topics are given here. right? Now you need to know how the temperature of the ocean is distributed, because this is very, very important for you to understand the oceanic currents, how the ocean water moves. See, when you go into the depths of the ocean and how the temperature of the water is there, that also you need to know. That is very, very important for us to understand the movement of the oceanic water. So come here and let's try to understand how the temperatures of the ocean water are present. See, you know that this is your sea, right? The deepest part of the sea is your trench. This is the deepest part. Now, where is the deepest part of the world ocean? It is Mariana Trench. It is deeper than the Mount Everest. Even you invert the Mount Everest, it will exactly fit, and still you have some water above. So that is Mariana Trench. Now, what I wanted to tell you is, as we go from the top to the bottom, that is from here to here, how do you find the changes in the temperature? Are the water is getting warmer? Are they getting colder? This is what you need to know, right? So let's try to understand. Imagine this is your surface up to 300 or 400 meters. Imagine this is your surface. So here the water is exposed to sunlight. Can I say that? The water is exposed to sunlight. If the water is exposed to sunlight, they will be warm. Beyond 200 or 300 meters, in this part of the area, you will not find any sunlight reaching there. So all of a sudden sunlight will be absent, because the water here 200 meters or 300 meters, maybe up till 400 meters, the water can be little warmer. But beyond that depth, the water cannot be warm. It will lose its temperature very quickly. That means, let's say, if this is a point of 27 degrees Celsius. Now, in this part of the area, the temperature will drop like this. From here, in the top layer as you go, the temperature might have dropped to maybe 21 degrees Celsius. But in this layer between the 300 meters to, let's imagine these are your 1000 meters. Here, the temperature will drastically drop to maybe 12 degrees Celsius. This is 21. The drop between first 400 meters is hardly 5 degrees or 6 degrees. But from here 21 to 12 or maybe 8 degrees, here you will find the temperature, let's call this temperature as 8 degrees Celsius. This is a drastic drop of temperature you will get to see. And from here to the bottom, the temperature is more or less 4 or 5 degrees Celsius. Even you go to the deepest part also, the temperatures are going to be 4 or 5 degrees Celsius, 2 degrees Celsius, 3 degrees Celsius. This is the temperature drop. Now, the place where the temperature is drastically dropping, this part of the area is called as a thermocline. Thermocline. This is called as the thermocline region. Now let me redraw it in a different manner. Let's try to understand the same concept. Let's imagine I'm going to take the ocean. One of the oceans I'll be taking into account. Let's say I'm taking the Pacific Ocean into account. This is your Pacific Ocean. All of the water I'm going to put into a bowl of 3000 meter deep. Let's imagine this is a Pacific Ocean. Okay? Imagine this is the Pacific Ocean, right? So here, let's see, this is 0 kilometers and this is 6 kilometers depth, and let's say this is 600 meters and this is 1000 meters, right? You will have water all over. Let's imagine there is water all over in this ocean till the depth. The distribution of temperature is that it is like this. Let's imagine the distribution of temperature at 0 kilometers, the temperature is 27 degrees Celsius. Just imagine. Okay, for our understanding only I'm taking this temperature. Let's imagine the temperature is 27 degrees Celsius. Why the temperature is high? Because there is availability of sunlight, right? As you go 300 or 400 meters depth, there is no sunlight, so the temperature will drop like this. Let's say the temperature from 27, it has dropped till 22 degrees Celsius or 21 degrees Celsius, right? As soon as it reaches to 600 meters, the temperature can be, let's call, instead of 22, I'll write it as, let's say this is 18 degrees Celsius, let's imagine. Now from this depth, 600 meters to 1000 meters, that the temperature drops drastically. Why? The sunlight cannot penetrate to that, so that's why absence of sunlight will lead to less temperature. And from here, the temperature drop you will see from 18 degrees to Sida, it will be 4 degrees Celsius. This drastic drop region is called as, thermocline, which is present at a high depth of 600 or 800 meters depth, right? Now beneath this, the temperature is going to be more or less stable. It is simply somewhere around 2 to, the temperature can be 2 degrees Celsius to 4 degrees Celsius, 0 degrees, 1 degree Celsius also. Now this is the ocean bottom ocean bottom temperature, right? In this ocean bottom temperature, you are not supposed to understand that water which is there at the surface is going to the bottom. Nah, this is not how the water is circulating. Let me tell you that one thing. I'll tell you about the circulation in the next 5-10 minutes, but try to understand one last time. These waters are comparatively warmer. Thermocline region is the drastic drop in the temperature, and at the ocean bottom temperature is more or less stable. And the water which is present in the top layer, this is first layer, this is second layer, and this is third layer. The water which is present in the first layer is called as surface water, and the water which is present at the lower region, these are called as deep water. Okay? These are deep waters, these are surface waters, right? And these are called as bottom water. Bottom waters and deep waters are different. Okay, let's not complicate ourselves. Let's call this as the bottom water or deep water. Let's keep it like that, because in the advanced classes we'll also get to know, in more than NCERT, you have to study something more than NCERT also. It's not, NCERT is not the sufficient entities to clear this exam, but these are the basics that you need to know, right? So 90% of the water is composed of this. 90% of the oceanic water is made up of this, and only 10% of the water is made up of surface. The total volume, if you take, 10% is surface, 90% is deep ocean water, right? 90% is deep ocean water. Let's come to understand in little more detail. So this is what is written in your NCERT also. Okay? The same thing, thermocline, this is your thermocline region. From 20 to almost, the temperature dropped till 4 degrees Celsius. From here, the temperature is 1, 2, 3, 4. This is what is. So this region is called as thermocline region, right? Drastically temperature drops, right? If the salinity drops, it is halocline. If the pressure drops, pycnocline. So the same lines. This is how the temperatures are drawn. But you also need to know salinity. See, you also need to know about salinity. How the salinity of the water affects. See, the salinity of the water is affected by multiple factors. Number one, look here. The salinity of water in the surface layer is of the ocean depends mainly on two aspects. One, evaporation. Second, precipitation. Right? One, evaporation, and second, precipitation. Next, the surface salinity is greatly influenced by the coastal regions. It is influx of the river. Can I say polar regions, by the process of freezing and thawing, polar regions will give you freezing and thawing, whereas rivers will also influence the oceans. Wind also influence the oceans. If the wind is more, it will evaporate the water more. Suppose if the wind speed is more, the wind will be moving faster and it will also help in evaporating faster. Likewise, the ocean currents contribute to the salinity variations also. We'll try to understand all of this in detail, but let me try to ask you, where do you find the highest saline water? The highest saline water in the world, you will find them in the Lake Van in Turkey, and it's not Dead Sea. It is Lake Van. That is 330 parts per thousand. This is how it is represented. How much is Dead Sea? It is 238. Now tell me, you might have heard about that if you're going to swim in the Dead Sea, you are going to float. But why are you going to float? It is because the density of this particular water is very high. See, your body has a density. If you're going and jumping into a liquid where the density of that water is more than the density of your bone or your body, you will definitely float. So the oceanic water or the sea water which is having a density of 238, you will not sink there because you will be lighter to the ocean. The water is more denser there. Likewise, the Great Salt Lake 220. These are the deepest waters, but now let's come to the Indian context and also try to understand this particular entity. In the Indian context, you will come across that the temperatures and variability of salinity is that, see here, come to India. Where do you find the highest salinity? The highest salinity in terms of Bay of Bengal and Arabian Sea. You look here. The salinity is influenced by the factors such as influx of water. Look into this is Arabian Sea and this is Bay of Bengal. Now you tell me, do you have more salinity in the Bay of Bengal or more salinity in the Arabian Sea? You have more salinity in Arabian Sea. Why? Let me tell you. See, in Bay of Bengal, you have Ganga river flowing here. You also have the Irrawaddy type Mekong rivers which they come, and here Mahanadi, Godavari, Krishna, Kaveri, and other small rivers. All these rivers are adding fresh water to this, right? Likewise, you also have Indus, Narmada only, and some small rivers. The total amount of fresh water that is added to the Bay of Bengal is more. So you take a mug. Here, the quantity of the fresh water is more and the quantity of the saline water compared to the Arabian Sea is less there. So there is more amount of fresh water which is added. Let's imagine this is a bowl and this is also a bowl, and this is the total amount of saline water and this is the total amount of saline water. But the rest of the water which is there, it is fresh water which is added in the form of rivers, and here only little amount of fresh water is present in the form of rivers. So that's why this is less saline. This is less saline and this is more saline. Okay? More saline, and this is less saline. So your Arabian Sea is more saline than the Bay of Bengal. Likewise, the salinity depends on multiple factors. Okay? You go to the polar region. In the polar region, there is lot of fresh water that is present, right? During the times of summer, the salinity will be little lesser. But during the times of winter, what happens is that the sea salinity gets little higher in the polar regions. Why? Because all the water during the winters will convert themselves into ice. All the fresh water which is there on the surface, they will convert them into ice, and the remaining water will be more saline. So that's why you have less salinity during the times of summer, more salinity during the times of winter in the polar region. Likewise, if the rate of evaporation is more, if the sunlight is too high and the rate of evaporation is very high, then you will have a better, more salinity. Okay? And in detail about this particular content, we'll also talk about this in the advanced batch of my personal batch, right? Okay. And geography, see, understanding geography is very important. Okay, no doubt you need to understand this geography, but only 10 days or 12 days is not sufficient to understand geography. You give me little more time in the classrooms, we will understand these beautiful topics in a lot better manner. Okay, I'll make sure that none of your questions which are there, they are going to be missed in the examinations. I'll make sure that 90% of the questions that you're going to attempt will be answered correctly. through conceptual clarity, crystal clear conceptual clarity, right? So this is what we do in the advanced classes, right? Okay. And you can also get in touch with me if you have any doubts there. That is 7382 552230. This is my contact number. Next. And no calls IR, only messages, right? And within a given time I will also definitely get back if you have any doubts. ठीक है, ये मत कॉल ये मत करना मतलब ये पूछने के लिए सर यूपीएससी के लिए कैसे तैयारी करना है यार. You need to know little basics, do the research, and then if you have any strategical problem, then you can also get in touch with me, right? Only drop a message, I'll definitely get back to you. Now come to the next further topics. You need to know the vertical distribution of salinity. See, the vertical distribution of salinity is that highest amount of salinity is not present at the equator. At equator, the highest amount of salinity is not there. The highest amount of salinity you will come across the places where there is in the tropical regions, especially in this part of the areas, the salinity is high in the tropical areas, somewhere here 20 degrees north, 30 degrees north. Why? Because here the sun's rate is also there in the summers and good rate of evaporation is taking place. But at equator, you see at equator every day there is evaporation and there is cloud formation. This will lead to rainfall. So whatever it is evaporating at the equator, the rainfall is there. In this part of the regions you will have rainfall, but the rainfall in these regions near to the tropical regions, the rainfall is less. So that's why the more saline water you will find them here. Now let me show you where do you find the high saline water. You will find that surface salinity of the world oceans, the highest salinity is found, look here, it is present in the tropics, not at the equator. See, at the equatorial regions the salinity is high in these areas. Look, equator has 35 parts per thousand. Okay, but come to the highest salinity, this is 37. Okay, tropical regions has 36 parts per thousand. These are the pockets, whatever the pockets I am drawing, these are the high saline areas. So comparatively, you go to the tropical areas, the salinity is high here, but not the equator. Equator has little less salinity because equator also has good amount of rainfall. Wherever you do not have rainfall, you will have less salinity. Sorry, wherever you do not have rainfall, there you will have more salinity, and wherever you have rainfall, there you will have less salinity, right? So these are the aspects that you are supposed to know. Now let's try to understand the concept of movement of the oceanic water. How does the movement of the oceanic water takes place? This is the next important chapter that you are supposed to know, right? It is written in both the aspects as well. So in the movement of the oceanic water, there are three different aspects that you need to know. One, what is a wave, what is a current, and how is it different from a tide, right? What is a wave, what is a current, and how is it different from a current? So here, let's see, you need to know the fundamental difference between wave, tide, and current. See, in the wave, the water moves like this. In a wave, the water moves, the water rises, water falls, and the water comes back to the same position. Okay? In a wave. And then the wave is it energy. See, remember, wave matlab water will not move for hundreds of meters. In a wave, the water always rises, falls, and comes back to the same position. A current is the one which will transport the water from one place to another place. The tide is rise and fall. Now first let me show you what is a wave. How does the wave looks? See, wave rises, it falls, and the water particles will come back, but the energy will move forward. Again, the water will fall and it comes back, but the energy will move forward. Okay? In a wave, the energy will always move forward. Now let me show you how the water moves in a wave. How the water moves in a wave. But tell me, what is a wave exactly? What is a wave? Wave is considered to be transfer of energy. For suppose, if I am shouting or if I am talking, I have sent sound waves. Nothing but I have sent energy from my voice box to the person who is sitting in the last bench. From here to there, I have sent voice box. Now this voice box, from my voice box, there is a wave that has traveled from here to the person who is sitting in the last bench. Now this wave is nothing but I have transferred an energy from here, from my voice box to the person's ear, right? So this is called as a wave. Wave is considered to be transfer of energy. So imagine this is your ocean. In the oceans, the wave behave completely differently. In the oceans, the wave behaves differently. How does the wave behave? Let me show you. See, wave moves like this. Let's say this is point B, this is point A. What is the direction of the wave? Direction of the wave is from point A to point B. Even in the oceans, the wave, if it is moving from A to B, it is not the water that is moving from A to B. It is actually the energy is moving from A to B. Okay? In the wave, energy moved from A to B, right? But water, how does the water move? Now let me take a different color for the stencil to understand how does the water move in a wave. Look here, the water moves like this. Please be careful in understanding this. Water rises, the water falls, and then that means this is the direction of the water. Let me show you that this is the direction of the water. Water rises and water falls, and then the water comes back like this to the same position. The water comes back to the same position. So the water rose, the water sinks, and water will come back to the same position. Again, from here you will come across the water rise, the water fall, and the water will come back to the same position. Again, from here the water will rise, the water will fall, water will come back. So always in a wave, the water from point A will not move to point B. Okay, how does the water move? The water will only rise, fall, and come back to the same position. Okay, water rises, water falls, and comes back to the same position. Right? Water rises, water falls, and comes back to the same position. Right? So in this manner, the water moves in a circular motion. This is what is waves. But what about current? In a current, the water moves like this. The water from point A, they will move further. This is called as current. So this is your wave, this is wave, and this is current. Now what do you mean by tide? Tide kya hota hai? What is tide? In a tide, the water will rise and fall. Look here, what does the water do? The water will rise and fall, but at a greater length. The water will again rise, water will fall, rise, fall, rise, fall, rise, fall. The rise and fall of the water is called as tide, and the circulatory motion of the water is called as wave. And if the water is moving from A to B, that is called as current. I know for many of the students, this might be something new to you, right? You might be experiencing that wave, matlab ab tak ye socha hoga that waves are the ones which are carrying the water from place to place. No, hardly. The strongest wave will displace the water by 20 meters. Hardly 20 meters is the strongest distance of the wave water displacement, right? Only 20 meter tak water will move further, but always the water moves further and comes back. So this is the fundamental difference between wave, current, and a tide. Now let's try to understand in little more further what are the forces that are responsible for the movements. And tides, I'll tell you how they are formed. tides are formed because of various reasons. Now let's quickly come to the concepts of ocean currents here. What are these ocean currents? What are the different types of ocean currents? Right? Ocean currents, and what are the different types of ocean currents? In this, there are multiple ways of ocean currents, major ocean currents, minor ocean currents, and these ocean currents are very, very important for you to understand. And this ocean currents you definitely have to know, right? I'll teach you how to remember the names of the ocean currents. Now, for you to understand this ocean currents, you definitely need to know about the easterlies and westerlies concept. Now, first, before I go any further, I wanted to tell you how the movement of the oceanic water takes place. See, the movement of the oceanic water are primarily driven by wind. Cold water wants to move towards the warm water, and warm water would like to move towards the cold water. That is why, see, the primary factors which are responsible for the movement of the water are: one, heat. That is difference of heat. In the equatorial region there is warm, and in the polar region it is cold. Right? It is little cold. Right? If it is cold here and it is warm there, so don't you think that this cold and warm water, it is going to be little different? Your cold and warm water will be different. It is cold, this water is cold, and this water is warm. So your cold water would like to come towards the warm areas, and your warm water tries to bring the warm water to the cold areas, because distribution of heat is something it wants to do. But see, how does this cold water move? Why does the warm water move? It is because of various factors. Wind also plays a vital role. Right? So first you need to know where do you find easterlies and where do you find westerlies. This we have done in the previous classes. But let me quickly remind you, where do you find easterlies? See here, these easterlies are present between 5 degrees north to almost 30 degrees north. This is the place where easterlies are present. All the winds are coming from the east in both the hemisphere. These are your easterlies, right? This is your easterlies belt. Where do you find westerlies? Westerlies are present in this particular area. The winds move like this from west to east, right? Likewise, the winds move like this from west to east, right? So you have easterlies belt, you also have westerlies belt. That means, don't you think the water will also move in the same direction? If the winds are moving in this direction, the water will move along with the winds. It is the wind which is moving the water, so the water will start to move in the similar direction. This is the directional movement of the water, right? Right? Imagine this is the directional movement of the water. Blue color is the directional movement of the water. Now you tell me, if the water is moving in the same direction like the wind, if the wind experiences Coriolis force, don't you think that water will experience Coriolis force? Yes, your water will also experience Coriolis force. So look here, this is your equator. Imagine this is your equator. Your wind is also experiencing Coriolis force. Your water will also experience Coriolis force. Your wind is the one which is moving the water. Suppose if the wind is getting water onto the coastlines, look here, if this is your India, if this is India, if the wind is getting the water onto the coastal areas, these are called as onshore winds. Okay? These winds are called as onshore. If the winds are moving away from the coastal area, if they are moving away from the coastal area, if these are the winds are moving away from the coastal area and pushing the water away from the coastal area, those are called as offshore winds. One is onshore winds, other is offshore winds. So you are also clear with the concept of onshore and offshore. So come back here, you need to know that the easterly winds which are there, they will try to bring the water from east to west. Now let's try to understand that this is a water which is moving in this direction, and this is also a water which is moving in this direction. That is, let's say this is easterlies belt, this is also easterlies belt, the wind is moving from east to west. The wind is moving from east to west. Don't you think the water will also move from east to west? Yes, the water will also move from east to west. And here the water gets deflected towards the right in the northern hemisphere. The water gets deflected towards the right. It is, instead of going in a straight line, they deflected towards the right. This is in the northern hemisphere. And the water gets deflected towards the left because Coriolis force is towards the left in the southern hemisphere. This is how the water gets deflected. The water can also get deflected because of the topography or because of the landform. So let me try to explain you in a detailed manner how does the water moves and how the water moves and what are the names of the current that are given to you, right? And whatever we are going to learn now are the water of surface water. This is your surface currents. This is your surface currents. How much percentage of water is surface currents? Surface currents are only 10% of the total volume, but these surface currents are the ones which are helping you to understand what kind of climate do you have. Wherever you have cold water, there you will have a good conditions for the fisheries and the temperatures will be cold, and also deserts will be present across the continent. If you have warm water, it will lead to the good rainfall in that region, right? These are some things that you need to note. Now come to understand this particular entity. Let me take you to the Atlantic Ocean and let's try to study the Atlantic Ocean in little more detail. See, there is a concept of upwelling and there is also a concept of downwarping. I have to tell you this. For this, please try to understand this particular concept. Imagine that, see here, let's try to look into this ocean, right? Let's try to look into this ocean. You know that, please try to imagine in a three-dimensional manner. Always geography will give you very good results, and for especially those optional students who are there, geography as an optional subject will definitely clear your prelims just like ease. Why you know? It is because 35 odd questions will be asked from geography and environment, and those optional students who are going to take, this is just NCERT classes. In the further classes, you'll learn about little more detail, and in the optional, you'll be a master in the geography. When you go with the mastery in the geography to the optional, you'll definitely clear the prelims with ease because 30 to 35 questions will be there, including geography and environment. And in these chapters, you are going to do wonders. Out of 35, even if you score somewhere around 27 to 28 also, fairly you will score near about almost 55 marks, and the cutoff is not more than 80, 90. So don't you think that by reading history, polity, science and technology, other subjects, economics also, can't you gain another 30, 40, 45 marks? Easily you will gain. And for those students who are having category, it is very, very easy for you to clear the prelims with ease, right? If you're thorough with, strong with geography and environment. Now try to understand this. Imagine this is your water. ठीक है, ये सब आपका पानी है. And let's imagine this water has a depth. This water has a depth. ठीक है? Try to imagine this perfectly. This water has a depth of thousands of meters, right? Now see, these are your water, right? So between tropics, you look into tropical latitudes, the winds that are coming are, what kind of winds are these? Are they easterlies? That means, let's say this, let me call this as east. Now let me call this as west. The winds which are present in this region are easterlies, right? Suppose if these are the winds which are moving from east to west, let's say these are the winds. They'll go around the earth like this from east to west. I already told you the wind that is moving, it is the same wind which will help in moving the water. Now you tell me, the water which is there, don't you think that it will also move in the same direction? Here the water is also moving in the same direction, and this water goes here, and imagine this is a land. Here the water will starts to sink. Here the water sinks, and the same water, the water sinks. If there is sinking of water, don't you think there will be cold water? The water sinks and here the water rises, right? It is the wind that is pushing the water, right? So this wind is the one which is helping the water to move. Now on one side you'll have warm water, on the other side you have cold water. Why this is water is cold? This water is cold here because there is upwelling that is taking place. This is cold because upwelling that is taking place, because the water is coming from the surface, somewhere around 400-500 meters the water is rising. Why the water is rising? Because the wind is pushing the water above. They'll shift its position here, they'll shift its position here, like that. Now this is called currents. On one side you have upwelling, on the other side the water is sinking. Can I call this as down warping? Right? So let's see the same thing in a practical way and try to understand this in a better manner. Imagine this is your Africa, right? What kind of winds do you have on Africa, especially if this is your equator? The winds that will be present here are they easterlies? These are easterlies. Now let's say this is South America. Okay? This is South America, right? So here the winds will start to move in the same direction, and you tell me these are the winds which will be moving in the same direction. Can I call this as onshore winds or offshore winds? These are moving from the coastline to the ocean, they are offshore. And these are onshore winds because from the ocean they are going on to the coast. Now let's see how the water moves. Let's imagine these are all your water. And please try to understand this in the depth profile. Okay, how the water moves, let's try to understand. In the depth profile, this water, please imagine the water in the depth profile and the wind in the above. So let's try to understand how the water moves. Here, the water has to move from this place to the other place, right? Because the wind is also moving in the same direction. This is how the wind moves, right? So this is your depth profile. I'm talking about the depth profile of the water. This depth profile of the water, let's imagine the depth of this water is somewhere around 500 meters or 600 meters. So as the surface water is being pushed away from here, they are pushed. So as they are pushed, don't you think that the water from beneath, from the below, they'll start to rise up, right? The water from below, don't you think they'll start to rise up? Yes, the water from below will start to rise up. From what depth? From a depth of 300 to 400 meters, the water will start to rise, and this rising of the water is called as upwelling. This is called as upwelling. And once the upwelling water, as these water will start to move under the influence of wind, they are exposed to the sunlight, they will get warmer. Now these winds will get warmer. Red color means warmer. Once they are warmer, they reach to the coastal area, right? And they will follow the path of the topography. Here, this water will start to sink to 400 meters. Once they sink to the 400 meters, they will get colder, and the same water will start to come back to its position. So like this, one circulation has happened in the depth. What is the depth of this? Let's say this is 400 or 500 meters. And this is surface. This is called upwelling, and this is called down warping. This is called down warping. There is upwelling also, there is down warping also, right? You got to see upwelling, you also got to see down warping. With this upwelling and down warping, you will now get to understand the depth profile. This is the depth profile. So here the water will be cold. This will be cold water, and this water will be warm. You tell me, if you have warm water here, will there be evaporation? Will there be low pressure? Yes, there will be evaporation. and you'll have rains. As you have cold water, will there be high pressure or low pressure? You have cold water, right? Here you have comparatively cold water. When you have cold water, you'll see this cold water will create a high pressure conditions, and this high pressure condition you'll have sinking air that I've told you in the previous classes, and there is no rain. Right? Here rain, because evaporation is happening. So this is how the distribution of oceanic water of first top 400 meters will take place. Now this is what I told you. Surface water means at what depth? Surface water means only till 400-500 meters. Now we are talking about only 10% of the volume of the water. Now let's try to come and understand how the movement of the water will take place as you go and look onto the surface. Okay, I'm talking now about the surface water, not about the depth profile. So at the surface, the water will start to move and follow the topography. Let's try to understand like this. Please try to understand this, and any doubts you can also drop me a message. I'll be happy to address your aspects as well. Look here. See, this is your equator. Let's imagine. So if the wind direction is like this, okay, and the wind direction is in this direction here, right? So now the color which I am using, blue color, is considered to be water. The water from here is moving in this direction, right? This is your water. The water will move like this. So for our easy understanding, I'll take a stream of water. This water will move. And I told you here you have cold water, right? Why do you have cold water? Because in the cold water there is upwelling that is taking place. And these water, as they move, they get warmer, right? As they move, they get warmer. And they follow the path because Coriolis force is deflected towards the right? And also this warm water, they get little warmer, and here you have cold water. Why? Because upwelling is happening, and here downwarping, depth profile mein downwarping. Under the influence of wind, as this is present near to the equator, this is called as north equatorial current, right? This is north equatorial current. In the southern hemisphere also similarly, the water will start to move and it follows the path like this. Here also you will find the upwelling of the water. Here the water is cold on the western coast. Now this water which has reached till the US, it will follow, deflect towards the right, because in the northern hemisphere anything that goes will get deflected towards the right. Likewise, the deflection is moving, and here you have westerlies belt. Don't you think this is your westerlies belt? This is your westerlies belt, right? As the water enter into the westerlies belt, the deflection of this particular water is towards right. Okay, it is towards right like this. Now all this water which has gone, they'll now come back to the same position here. This is your cold water is there, no? Here this is the region of cold water, right? Now the entire water has made a circulation. Why? Because here there was upwelling, here there was downwarping, and then the water follows the Coriolis force direction, and the warm water would always like to go towards the polar region, and the polar cold water would always like to come towards the warm region. In this manner, you will get to see the movement of the water. But see here, this warm water would also love to go towards the cold region, and cold water from the polar region wants to come towards the warm region. So here is the place where you will get to see the cold water and warm water getting mixed. Wherever you see the mixing of the cold water and warm water, that is the best place for the fishing grounds, right? So this one full circulation of water is called as gyre circulation. One full circulation of water is called as gyre circulation. This gyre circulation is if the water which is present in the center of this circulation, if it is not moving much, they are stationary. The water in the center, this entire water which is there, the movement of the water is not too much in the Atlantic Ocean. This is also called as Sargasso Sea. This is also called as Sargasso Sea. Right? So this is your Sargasso Sea. And see, as this water is warmer, warm water which is going to the polar regions, now the places which are near to the polar regions such as your British and your Norway, though they are having very cold temperatures, but their ports will not freeze. The water across the ports will not freeze because this warm water is the one which is going towards their area. That is the reason why their ports are always open all throughout the year, irrespective of there is snowfall, there is ice in their areas. But a similar ports in the same latitude of North Korea, their ports will be frozen. Russia's ports in the same latitude. See, you take this latitude, if this is the latitude, in fact, in Canada also their ports are frozen. In Russia also their ports are frozen. They cannot operate their ports that easily. But your Norway, British and these areas, they are able to handle their ports very freely because this warm water, literally they have to pray to this water. This is called as North Atlantic drift kaha jata hai. This drifting, the water is drifting to the north, that is why it is called as North Atlantic drift. ठीक है? This is called as North Atlantic drift. Whereas likewise, there are names that are given to these currents. See, here you will have a island called Canary Current. This is called as Canary Current. Right? Because there is an island by the name Canary. Now this is the Gulf of the USA. This is the Gulf of the USA. So that's why the name of the current which is given to this warm water is also called as Gulf Stream. This is your Gulf Stream. So this is called as your Gulf Stream. The places, I also want you to keep your atlas open. Now in this manner, look, this is your current. This is North Atlantic drift. This is North Equatorial Current. This is Gulf Stream. This is Gulf Stream. Right? And this is Canary Current. So the names of the currents are just the places which are present next to each other. This is your North Atlantic drift. It is going to the polar region. So this is given, they are drifting to the polar region. So this is called as North Atlantic drift. Now this is the same reason why you will have the movement of the ocean water. They are making a circulation, a similar kind of circulation also seen in the southern hemisphere. Why? Easterlies are bringing the water, and the water, once they come to the other side of the coast, they will get warmer. Wherever you have offshore winds means the winds are moving offshore, the winds are moving like this away from the coastal area. If the winds are moving away from the coastal area, these are called as offshore. Wherever you find offshore winds, there you will find upwelling of water. The water tends to rise above, right? And the same water will move towards the other end. Like this, you will see all the circulations across the globe, they are given different name. Now, the water which is moving in the southern hemisphere, this is given as this is a north equator के पास है. In the southern hemisphere, this is south equator के पास है. So south equatorial, this is current. This is south equatorial current. If you're okay, let me erase and then I'll show you what are the names of the currents that are given. In a similar manner, you go to the Pacific Ocean as well. The Pacific Ocean will also have similar kinds of currents. Let me show you the names of these currents which have a unique phenomena. Right? See, you also have your atlas. Keep open your atlas and try to look into this. I'll be pointing out the cold water currents. See, wherever I'm going to put this blue color, it's an indication that this is your cold water current. So it is not much visible. So let me do it with the dark color. This is your cold water current. Identify this cold water, one cold water, right? So here California has cold water. Canary current is cold. You know why it is cold? Because यहाँ पे ऑफशोर विंड्स है, जहाँ पे ऑफशोर विंड्स होगा वहां पे कोल्ड वाटर होता है क्योंकि अपवेलिंग है. Likewise, this is your Ovesho current, which is cold water. Here also, Peru, next to Peru, you have Peruvian current, which is cold water. Benguela current, which is cold water. West Australian current, which is cold water. See, the names of the currents are just given on the basis of the locations which are present to next to each other. Right? You have cold waters and rest of them are warm water. Now, using the black color, I'll be showing you the direction of the winds. So please see, this is your equator. Right? This is your 30 degrees north. The winds in this particular direction are easterlies. Here also you have easterlies. Now they are westerlies. Right? Where do you find westerlies? You find westerlies in this belt. Right? So you see, you find easterlies still here. Now, are these winds offshore or onshore? The winds are moving away from the coastal area, right? Black color sketch which I am using is winds. So you see, do you find onshore winds or offshore winds? This is the direction of the winds, right? Right? This is the direction of the winds. So you tell me, where do you find onshore or offshore winds next to California? This is a place, right? These are offshore winds. If the winds are moving away, they'll also push the water away, so that the water from the bottom will start to rise up. From 400 meters, the water rises up. Now the temperature will be little colder. So here this water is cold current. And the city that is present here is California, and the state that is present is California. So it is given Californian current. Likewise, you also have a place called Canary. Offshore winds, Canary Island होता है छोटा सा. This Canary Island के कारण, this Canary Island is the reason why you have Canary current. This is named as Canary current. Right? This is Canary current. Right? Likewise, you see, entire world has different currents. These currents are driven by one. The warm equatorial water wants to move to the cold air regions. The cold polar region currents wants to come towards the equatorial regions. And this water is also driven by the wind. While they move, they are deflected towards the right by the Coriolis force and towards the left by the Coriolis force in the southern hemisphere, towards the right by the in the northern hemisphere. So let's once try to understand the movement of the water in the South Atlantic Ocean and try to apply this. Look here. The winds in the South Atlantic Ocean are offshore winds here. That means you will come across the movement of the water is in this direction and there is upwelling taking place from the bottom, right? So this water which has reached over a period of time this place, it is obstructed by the topography of this South America, and then they'll start to drift because apply Coriolis force. Coriolis force is towards left. If suppose the water is moving in this direction, their left is this side, right? It is towards this. If the water is moving in this direction, apply Coriolis force, it is towards left. So that's why they drifted. Now once they entered into this westerlies belt, this is westerlies, right? From the west to east it is. And remember, this is your east, this is your west, right? So this is your western side, the winds are coming from the western side, the water will be drifted again towards the westerlies and apply Coriolis force. If the water is moving in this direction, the Coriolis force is towards left. So here in this region, the water again drifts back to the same position, and this is your cold current. The names of these currents are just places across them. These places are none other than, look here, there is a place called Benguela. This is your Benguela current. Now the name of this current is, it is present south of the equator, so south equatorial current. Likewise, this is your Brazil, so Brazilian current. So, and this entire circulation of water is called as gyre circulation. This is called as gyre circulation. Now like this, there are good number of gyre circulations across the globe, and this is how the oceanic currents flow. Wherever you have cold water, there will be upwelling, and at this upwelling you will have good fishing grounds, right? You will also have good fishing grounds at places where that is like this. One, wherever you find the cold water and warm water, this is one place, this is also another place, this is also another place, right? These are the best places across the globe for fishing. These are fishing grounds, right? Now this is what is all about currents that you need to know. Places and all, again, see, we'll learn in a detailed manner about each current and how they form, how they move in a detailed manner. Now coming to the last topic which is there in this particular chapter that one has to know here is about the tides. Okay, what are tides and how are they formed? Okay, what are tides, how are they formed? See, there are different types of tides. How are they formed? Tides are formed because of the gravity. Gravity of what? Let me quickly show you how these tides are formed and the significance of gravity. See here, around the earth, moon revolves, right? Earth and moon revolves around the sun, right? So look at this. This is the earth. Moon goes around the earth and it takes how many days? How many days for you? It is how many days? 10, 12, 14, 28. Takes 28 days for the moon to go around, almost 1 month, right? So see here. Now I wanted to tell you how these tides are formed. Just a minute. These tides are formed because of the gravity. Gravity of what? Gravity of moon and the sun. Look, the reason for the formation of the tides is like this. The major reason for the formation of the tide is gravity. In fact, gravity pull. Now, if suppose you have the bigger body, if bigger the body, the gravity will be more. Okay? If smaller the body, the gravity will be less. Right? If bigger the body, the gravity will be more. Smaller the body, the gravity will be less. Look at this. This is your sun. This is your sun. And this is your moon. Moon only has less gravity. The second factor for the gravity is the distance. Okay? The second factor of gravity is distance. See, if suppose, if closer the body, if two bodies are closer, the gravity will be more. If two bodies, if this is one body and another body is far, right? The distance is very far, the distance is less, right? If the distance is far away, the gravity will be less. If the distance is far away, the gravity will be less. Now you are supposed to understand two things. One, distance. Second, size. These are the only two factors which influence the gravity, right? So you see, who has bigger body? Sun is the bigger body, so sun should have more gravity, right? And you see, sun being the biggest body, the gravity of the sun is very high. The gravity of the sun is very high. The impact of the gravity of the sun is also there on the moon. The impact of gravity of sun is also there on the earth. Likewise, the gravity of moon is also there on the earth. But the factors of these two, such as size and distance, if you take together, see, the gravity, though the sun is bigger, sun has more gravity, and the moon is smaller, moon has less gravity as compared to sun, but the influence of the moon's gravity is more on the earth than the sun's gravity on the earth. How? See, as from the sun, the earth is very far away. This will be your earth, right? It is very far away. But for moon, the earth is very near, extremely near. So look at the distance. Look at the distance. So that's why the influence of moon's gravity on the sun on the earth is more as compared to the influence of sun on the earth. So that's why if you look into, our tides are decided by the moon more than the sun, right? And I'll also tell you how these tides are formed, right? And at what distance at what time the tides are formed. So that's, you look here, if you take 16 as a whole, 11 units come from the moon, the gravity of 11 units come from the moon, and the gravity of 5 units come from the sun, right? The gravity of, out of 16, 11 times, it is the ratio you take, 11 comes from the moon and 5 comes from the sun, right? It is like that, the ratio, this is how, that means there is, the influence of gravity of the moon is double than the influence of gravity of the sun, right? Okay, see here, you know that this is your earth, and what does the earth do? Earth rotates, it rotates, right? As and when it is rotating, there is moon that is present here. At every point on the earth, imagine this is, if this is a point, if the earth rotates, this point will go and face the moon at one or the other point of time, right? If this, let me put this point here, right? Let's imagine the earth is rotating. Now this point will go around and it is going to face the moon, right? Within 24 hours, it is going to face the moon at least once, right? And this point will go all around the earth and again come back to this position. There is a time that is taken. So here, earth is also rotating, moon is also rotating, and moon is also revolving around the earth. So it takes 28 days for the moon to go around, but earth takes 24 hours to rotate. While it is rotating, every day you will come to one such position. Imagine this is a person. This person will see the moon, right? As soon as they go on to the night side, they'll see the moon. Imagine this is your sun. Okay, let's say this is your sun. Sun rays is there, and this is the portion of the earth where you will have sun rays. So this person is not able to see the moon, but a person who is standing here, for him it is night time. Okay, don't you think this is his night time? The sun's rays which are falling on the moon, they are reflected back like this. They are reflected. The sun's rays, let me put the sun here. The sun's rays, these sun's rays are also there on the moon. They go and reach the moon and they are reflected back like this. That is why these people who are able to be here, they are able to see the sun. They are able to see the moon, right? right? So this is your dark side of the earth. This is your dark side, right? Clear? Always there is a high tide in a 24 hours minimum, and one high tide and one low tide you will definitely experience. And how does this high tide and low tide will experience? Let me try to tell you. Look here. Let's imagine that this is your moon. This is your moon, right? So moon will have the pull on the earth, right? Moon will have the pull on the earth. For South America to face one full to make one full circulation around the earth, rotation around the earth, it takes 24 hours. That means South America is going to face the moon after some time. Now whosoever is going to face this particular moon, they are going to face a high tide. In a layman terms, let's understand like this. It is like this. Suppose here, let you please imagine that there is a moon here. I'll erase it, but you keep on imagining that there is a moon here. Let's imagine and see here that our earth keeps on rotating. Imagine that there is a moon there. Now see, let's focus on India. Let's see, this is your India. As soon as India faces this particular moon, here you have water. This water will be pulled by the moon, and this is the place where you will get to see high tide, right? If this is the moon, moon actually tries to pull both the solid and the liquid, right? As the solid cannot be moved that easily, so the liquid has the buoyancy force, so the liquid will move and again come back. So this is called as a high tide, right? Now after some time, see, after some time, this is your India now, but after some time, what does India do? India will go little further. Now who will see the high tide? The high tide will be seen by, let's say, this is Africa. Now this Africa, if you have the moon here, this is moon. Now here you will find high tide, right? This high tide is because of the moon pull. Moon is pulling. That is because of the gravity pull. And you see, as the earth is continuously rotating and at one or the other place is always exposed to the moon, you will have the pull of the water, right? So exactly on the opposite side also, if suppose there is a high tide which is present here and this is the moon, exactly on the opposite side of the earth also you have another high tide. This high tide is called as inertial tide. It is because of inertia. Now to tell you what exactly is an inertia in simplest terms, imagine anything that is in motion will tend to be in motion. See, earth is moving and it will tend to be in motion, right? All of a sudden you are trying to pull something from the earth by the moon. So equal and opposite reactions will be there. This opposite reaction will also throw a high tide here. For example, you're traveling in a bus, you sat in the bus chair, all of a sudden the bus which is moving, the driver gave a brake. You will tend to go forward and then come backward, right? See here, anything that is in motion will tend to be in motion. So earth in motion tend to be in motion, so some amount of water is pulled on the other side, on the moon side. So a equal and opposite reaction here, you will also see an inertial tide, because see, while you are traveling in the bus, just imagine this is the earth, and instead of earth you consider yourself this as a bus. As it is moving, all of a sudden the moon has pulled you. That means you move forward and then come backward. In a layman terms, I'm trying to give you this explanation. In the advanced classes, I'll give you a beautiful understanding in a detailed manner which is required for the examination. Now see here, as it is tending to pull, you move forward and an equal and opposite reaction, you will also come backward. So this is nothing but your inertial tide. So at every given point, you will have a high tide. This is high tide, and this is also a high tide. And at this particular place, from here, the water is pulled to either sides. The water is pulled towards either sides. So this is the place where you will have low tide. And exactly on the opposite side of the earth also you will have low tide, right? That means there is one high tide at this place, you will have another high tide at this place. This is inertial tide, this is gravity tide, and this is the place where the water of the ocean is pulled onto either sides, because the total volume is the same, right? Imagine this is a bucket. For one side, if you're tilting the water from one or the other place, only the water has to move from this place to another place, right? So likewise, just imagine that the level of the water here will become low for some time, and this level, all the water will be pulled towards this side, towards that side, and here you will have a low tide, this low tide, right? And here you will have a high tide. Here you will have a high tide. This is gravity tide, gravity pull tide, and this is inertial tide. So this is how the formation of tides take place, and this is your low tide. Now there are different names that are given to the tides. See, if the sun, moon and the earth are in the straight line, see here, you have your sun, this is a full moon, and this is your sun, right? If sun, moon and earth are in the same line, don't you think in this case, let's see that if the sun, moon and the earth are in the same line, let's imagine that this is your sun and this is your moon. Now moon will also be pulling, sun will also be pulling, so in this case the high tide will be more high, and the opposite side also the high tide will be more high. If sun, moon and the earth are in the straight line, this position is called as syzygy. This is called as syzygy tide. Whereas if sun is here and the moon is here, and the angle between the sun, moon and the earth is 90, this is called as neap tide. Okay? This is called as neap tide. So let me show you the positions here. If sun, imagine this is your sun, either it is full moon day or new moon day. New moon means no moon, the Amavasya. It is Kala Ratri, or else you can also say this is a black day in the night, a black night, right? So this is new moon. New moon means don't think that you can see full moon. There's no moon on that new moon, which is also called as Amavasya, because the sun is blocking the entire rays. But here the sun's rays are fallen onto the moon and they'll reflect. See, this is how the sun's rays will be there. If they are in the straight line, they are called as syzygy, syzygy, and here the tide will be coming, it will be little high tide. That tide is called as spring tide. The tides when they are in the same line, they are called spring tides. These are considered to be the highest tides. So that's the reason why you are asked not to go on a full moon day to the beach, or not to go on an Amavasya, or else on a no moon day or a new moon day to the beach. You are not supposed to go. This is what is the myth behind it, right? The religious things that they say, this is what is the reason behind it. Now either if the moon is and the sun, earth are making a right angle, look here, this is the right angle, so this is called as neap tide, right? This is called as neap tide. So in the first quarter and the third quarter, this is first quarter and this is third quarter, you will have neap tides. You will on the full moon day and the new moon day, second and fourth quarter, you will have spring tides. Now this is what you are supposed to know with respect to the entire oceanography. See, this is how the moon pulls On one side, you'll have the tidal bulge due to gravity, and this is tidal bulge due to inertia, right? So this part of the earth, the water is, some water is moved towards this side and some water is moved towards this side. So the tide will be little low. Okay? This is the place where you'll have low tide. Likewise, the entire earth will see at least one high tide and one low tide in the entire day, right? So this is what you need to know with respect to oceanography. I hope you had a good basic understanding of this, and if you have any doubts, you're always free to get in touch with me. Thank you, and in the further classes, I'll take up more sessions. And those students who are thinking of geography as an optional, you can always get in touch with me. I myself will be teaching you the geography optional in a beautiful manner. Thank you, and see you in the further classes.